I'll be presenting with my colleague Alex Akinbi. We're both at the Manchester Metropolitan University, just down the road here. And we're going to be talking about generative AI, which hopefully everybody is familiar with. You know, it's been a big topic in the news, in the media over the last couple of years. And particularly we're going to be thinking about some of the online harms arising from artificial intelligence, and particularly this kind of new flavor of artificial intelligence, the generative style of artificial intelligence. The way the talk's going to work, I'm going to spend 10 to 15 minutes. I'm just going to give an overview of some of the techniques, some of how these models work, try and kind of open up some of the ideas of what the models are actually doing from a kind of not too technical perspective, as in throw things at me if it gets too technical, you're very welcome to. And then my colleague Alex is going to talk about some of the harms and some of the strategies for mitigation of those harms, looking at the kind of academics perspective and the research on how do we go about mitigating those harms. So I wonder where you were in November of 2022. I wonder if you remember the first moment you saw it on maybe, you know, social media. I think there were news articles. Yeah, on the BBC News, I remember seeing an article about large language models, and I thought, that's my research. That's the thing that about 20 other people are interested in that I'm doing. And suddenly it's a global affair. I remember seeing it on Twitter and seeing people starting to post responses, post things that were coming through from this new language model called ChatGPT. We'd kind of heard about things that GPT was able to do. GPT-3 was behind a paywall at the time, so we had some access to it, but we didn't have loads of access, and we started to see that it was good at some of the tasks that we were interested in, but we in the research world, I don't mind saying, we're very much caught off guard by just how powerful it was, how capable it was, and the things that it could do. You can kind of see the image there. I wonder if this is your view of ChatGPT when you interact with it. I'm going to take an assumption that everybody has tried typing something in and seen what comes back for it. If you haven't, go do it. You know, it's fascinating. But I think we're far enough in that most people have engaged with it, or even if you don't know you've engaged with it, you've probably read something that was written by the same technology as you've browsed the internet. Even now, if you Google, if you enter a search query into Google, you'll get some, you know, AI generated response or the same for Bing. So there's a high likelihood that you have interacted with this technology. I wonder if this is how you feel when you interact with this technology, you know, the robot machine, the conscious sentient entity that's responding to you. And I can tell you, you know, the more and more you interact with it, the more you find that it's not this, it's really not. But I think it's very easy to feel that and to get that sense. I, as a researcher on artificial intelligence, and particularly the branch of artificial intelligence that's called natural language processing, I want to try and give you guys a bit of a perspective on some of the technology behind what's going on here, try and counteract this view of the kind of robot, you know, the cyborg behind the machine. A little bit of history then. So in May of 2022, OpenAI released GPT-3. There had been prior models to this, GPT-2 and GPT-3 then released in May 2020. We'd seen with some of the prior models, GPT-2 particularly, there was some kind of controversy in the media earlier to this. They didn't want to release the model itself for people to use. They were worried about fake news generation, and honestly the model wasn't quite good enough to do that at the time. Similar with GPT-3, OpenAI said we're going to keep it behind the paywall to limit usage of it, not make it or not allow it to be publicly usable. GPT-3 is specifically trained as a machine learning algorithm to take a sequence of text, a partial sentence, and to predict the next word in that sentence. I'll show you an example in a second of what that looks like. To get the next step, we get to January of 2022 and a model called Instruct GPT. This is the same model as GPT-3, but with further tuning, further training. And the training is not to predict the next word in the sequence, but to produce responses which look like example responses to instructions. So the classic example is if you write a prompt that says something like, write 2 sentences about X, about, I don't know, whatever you like, whatever your topic of interest in. GPT-3 will just write continuously, or it will, try to continue the instruction. It will do the kind of next sequence prediction task. Whereas Instruct GPT is trained to follow the instruction, to stop after 2 sentences. The problem with this is if you ask a language model or you train a language model to follow instructions, it kind of does the job too well. It follows any instruction. So if you say, how do I make a bomb? It gives you. And if you say, where do I place that bomb to maximize casualties? It gives you the answer as well, which is obviously very dangerous and not something that we should allow. And so the third element here is some kind of safety layer, which brings us to November of 2022 and the Chat GPT model, very much done in the same way as Instruct GPT training on how to follow instructions using reinforcement learning through human feedback, something we won't go into now, and then the safety layer using further reinforcement learning to train the model which instructions not to follow, which instructions to follow. If you've played with these models, you'll know that there are certain ways that you can break that safety layer, and there's a whole research field that's begun around finding ways to exploit these models to get around the safety layer to, with the intention of identifying areas of vulnerabilities that can then later be improved upon. So I mentioned with GPT-3, the idea is this next word prediction. And ultimately, these models are fundamentally doing this task, next word prediction. There's no other task that these models are trained to do. The only thing that they're designed to do is, given a partial sequence, predict the next element in that sequence. You can actually use these models for all of the types of sequences. DNA as a sequence, you can use it for next sequence prediction, and that you can use it for, all kinds of things, speech, images, etc. But the way we do language is through this idea of next word prediction. So imagine you have a GPT-3 box. We're not going to open that box right now. We're not going to worry about what's inside of that box, but you give an input and it does next word prediction. So at the moment, our prompt is just a very, very simple prompt. Remember, this isn't the instruction fine-tuned version. This is just predicting the next word in a sequence, and we have the as our prompt. But there's some words that could go in there, aren't there? Some sensible words that could fill it. There are words that wouldn't work in there as well if we predicted the full stop. This would be an incomplete sentence. It would be wrong if we predicted the, again, you can't have a sentence that starts with the. But GPT-3 predicts the cat, for example. And then what's going to happen now to generate our response is that word becomes the next element of the sequence. So we now have a new partial sequence, the cat, and based on that partial sequence, part of a sentence, we then do the same thing. So the cat, you know the sentence, right? Sat on the, and at each point we have some partial sequence. That partial sequence is fed back through the model. The model does another prediction step to predict a single word. In fact, it actually produces pieces of words as it goes through. But for our purposes, we can think of it as predicting a single word at a time. until we get to some end sequence, at which point it predicts a end sequence token. And we have a full sentence here. Why is this important? Well, thinking back to, I won't go back, but thinking back to that earlier image of, the robot behind the machine, this is fundamentally different. This is an algorithmic construct, and we can fully describe every element of how this works, of what this does, and how these predictions are made. And thinking about conversational AI, I'm actually just going to show a couple of examples of interactions with ChatGPT here. So here's one: name 2 football teams that play in Manchester. This is my prompt. And you'll see ChatGPT is the green box here. The 2 football teams that play in Manchester are Manchester United and Manchester City. What do you think of that answer? Is this good answer, bad answer? Good? Yeah, indeed. So it's kind of okay, isn't it? It makes sense. But there's also lots of other elements to that question, aren't there? Well, for a start, there aren't just 2 football teams that play in Manchester. There's, I don't know, probably hundreds if you go down to the lower leagues, but certainly if you stay in the leagues, one of those teams doesn't play in Manchester. United play in Trafford, right? They have Manchester as the name, but they don't play in the city of Manchester. They play in Greater Manchester, I'll give you. Anyway, you can see as well, one of the things that it does is a lot of copying. So you can see in this response here, name 2 football teams that play in Manchester. About 40% of this response is my words. You see that? 2 football teams that play in Manchester. Direct copy, right? This is what it's trained to do. It's trained to produce things that look like faithful responses based on the input that has been given, okay? And this is exactly what it's doing. So we get to Manchester, the next word it predicts is the next word it predicts is 2, and then it just copies, and then we get some sensible response as a result of that. And, we've kept on going. Which one plays at the Etihad Stadium? Again, you see a lot of copying, plays at the Etihad Stadium. Manchester City is the correct answer, and a bit more information as well. And this is the kind of thing that it's generally quite good at, being able to do this kind of factual recognition. Why is it able to do this? Well, the data it's been trained on contains this kind of information, the patterns that it's seen, the ways that it's learned to predict next elements in partial sequences, contains this kind of information. Here's another example of our interaction. What is 5 plus 5? The sum of 5 and 5 is 10. Great. Technically, it shouldn't be able to do this. There's no way or no reason that it has the capacity for mathematics. And the only reason it's able to do this is because, well, 5 and 5 equaling 10 will have appeared somewhere in its database. It's not doing a calculation. It has no capacity to visualize 5 and visualize another 5 and count that they exist, or that 10 exist as a result of that. We said, let's play a game where 5 actually means 6, and it agrees. And we said, what is 5 and 5? And you can see at the end here, it gets the answer right. 5 and 5 would be 12 in this game. And this is different to the interaction before. This one is a very factual-based interaction. But in this one, what have we done? We've taught the language model a new task. And this is probably one of the most interesting and exciting areas in large language models. We can call this in-context learning, the ability within an interaction to teach a task and to get a language model to perform that task. Okay. Some of the areas that we see conversational AI being used, and I'm sure you've seen this already. One of the newest areas of large language models is the idea of multimodal large language models. This means different forms of data going into the language model. So rather than just text going into the language model, you can see different forms of text down here. We can also see different forms of information, images, videos, speech, also going into the language model as well. And the language model being able to not only consume diverse forms of information, but also to produce diverse forms of information as well. We also have the ability to generate images using a technique called diffusion using generative AI. I won't bore you with the details because I'm low on time, but I will show you an image. So what we do effectively is we take some random noise you can see on the right-hand side of the image there. We give a prompt and we train the diffusion model to iteratively make that noise more like something that represents the prompt. And we get something like this as the noise coalesces into some form of picture. And this is just done iteratively by each step feeding the result of the last step back into the language model until the image that appears represents the prompt that was given. Okay, and I'll hand over to Alex now.
Thank you. All right, thanks, Matt. So I'm going to be talking about some of the arms or the offensive parts of AI. And my colleague Matt here mentioned things like using multimodal LLMs to generate not just text, but it's progressed now into generating things like audio and also images. So as you can see in that picture you got there, the original image on the left, and you have a deep fake. So deep fake all right, okay, thanks. So the deepfake compiles hoax images and sounds using AI models. So the process is you can take an original image and then you could create a deepfake by embedding a layer of someone else's image on top of another image to create a deepfake. So what we have now is a new image, taking someone else's image and embedding that on top of the original image. So the process involves feeding the footage of two individuals into a deep learning algorithm, the AI model, to train it to swap faces. So then you can't really tell which one is original or which one is fake. So deep fakes are appearing, not just in social media. You can find deep fakes even on YouTube, on a lot of platforms where it's being used to fool people and use it to sort of like confuse and cause a lot of confusion by creating hoax images. So deepfakes can be used for nefarious purposes, such as spread false information, identity theft, scam, and social engineering. So this is the new form of challenges that, even with the good things that we've seen with ChatGPT, where you could do a lot of things like conversational AI, which Matt mentioned, it is now being used nefariously by people to sort of like, this is the new techniques that we can use to sort of like create social engineering scams online and identity theft. So most of these models are open source. Some of them you have to pay for, some of them are open source. So 95% of deepfake videos are actually generated with this Deepface Lab, which is something you can download on GitHub, and you could configure your Linux operating system to generate this sort of images for free. So a lot of people have access to this. It's not something that you probably so it's like the cat is already out of the bag in this sort of scenario where you have people that publish models online that people can use freely to create deepfakes. So 95% of deepfake videos are created with this. So another classic example here is somebody using on a conference video call, and in real time they're able to embed their face or swap the faces with someone that looks like Keanu Reeves. As you can see, the image that has been generated looks exactly like Keanu Reeves in the video call. Okay, so even in real time, you can use these AI models to generate in real time audio conversations with people, embedding on that person's face and pretending to be who you're not. You've probably seen this if you're on TikTok. These are two people. Can you tell who is on the right or who is on the left? Anyone knows who this is? Tom Cruise. So who's Tom Cruise in these two images? On the right. Are you sure? Okay, good, good. I think that gave it away. Yes, you're right. So the image on the left is a guy called Chris Umi, and is TikTok vlogger, and he creates a deep fake of Tom Cruise. As Tom Cruise is aware of this, but just for sort of social media and getting a lot of likes and a lot of conversations online. But as you can see, it is quite difficult to identify who exactly is Tom Cruise. So Tom Cruise, the real Tom Cruise, is on the right, and then you have this guy, Chris, on the left, who is actually pretending to be Tom Cruise. If you listen to some of these videos on TikTok, you'll probably be able to tell probably with the voice. The face looks almost similar, but the voice might be something that actually gives it away a little bit. Or if you have these two images side by side, you might be able to say, well, I think this looks more like Tom Cruise, depending on the style of the hair on the specific day. Okay? So moving on, other arms are what we call voice cloning as a service. So you can't just create deepfakes. Now you can also create things like audio deepfakes, where you can clone people's voices by synthesizing their voices to mimic human voices. All you have to do in this sort of platforms is just write a speech. So you've probably seen a lot of videos on YouTube where people are that are just generated by AI. Someone could write a script or could write a voiceover and feed into an AI to use the voice of someone like David Attenborough to sort of just talk over that specific documentary. So there are softwares like 11 Labs, Resemble AI, Speechify. Some of them you have to sort of subscribe, pay some sort of like £20 a month or something similar to that. And you can use these models to sort of generate voices of known actors, or even generated voices of somebody you actually know. So you can actually replicate someone's voice by providing a sample. So all I have to do is, someone recording my voice at this moment, put it onto this AI models and use that with a speech, with a text to speech, generate, a whole conversation or a whole speech voiceover using my voice. So we can see now that even with the good things you can do with AI, for nefarious purposes, people are beginning to use this tool to sort of scam people online or on the internet, sort of so you can't really tell who's talking to you on the phone. Just a short 30-second video.
And you start getting into these, what I call local maxima, where you don't realize basically how dumb you were. This is a deepfake example of what is possible with a powerful computer. And it took around 72 hours to create this example from scratch using extremely powerful GPU. It could improve with more computing time, but 90% people cannot tell the difference.
Right, so you can see from that quick video there, that's Elon Musk. The video on the left was originally by Elon Musk, but the other one on the right was generated with deepfake, just as in the video. But looking at those side by side, it's hard to tell, which is real or which is fake. So how deepfakes can impact individuals and organizations? I'm just going to talk through this real quick. Impersonation for financial gain. So somebody can, impersonate somebody for financial reasons. Executive impersonation for brand manipulation, so somebody can just publish something, say anything online, and then the stock price, begins to fall. Impersonation to gain or obtain sensitive information, disinformation, fake news. These are all of the nefarious harms that people can use deepfake to sort of create. Just earlier this year, in February, a finance worker actually paid $25 million after a video call with somebody assuming to be the chief financial officer in Hong Kong. So they were on this video call with other executives, and the person they were actually talking to was not actually the chief financial officer. And they were able to get the finance worker to actually approve $25 million by just something like in a Zoom meeting or a Zoom call. So there are challenges of how deepfake is now being used to scam, to create a lot of social engineering. You can find countless examples in the news relating to these types of deepfakes that are being used online. So how do we combat or mitigate some of these approaches? Detection of deepfake. So one of the things we're working at MMU as part of our research is to identify or create tools that can spot deepfake. Like Matt mentioned earlier on, most of this conversational AI are using sort of predictions where embedded inside of them is what you have, what we call tokens. So if we can create tools that could help us spot these tokens within an image that's been generated using AI. Does that make sense? So you can use tools to detect if something has been generated with AI by looking at those images and trying to identify tokens within those generative text or generative audio. Another thing is what we call watermarking. So if you generate something with OpenAI, it will contain watermarks that can help an AI detection engine to determine that it's got a watermark and therefore predict that it was actually being generated using an AI or a large language model. A lot of these images, videos, and deepfakes as well would contain noise, all right? And if you look at the spectrum of these images, you can actually, if you take a real image that was generated or probably taken with a picture of a camera on your phone, and you compare that image with an image that is generated with AI, you would detect that there are lots of like noise within the spectrum of that specific image compared to a real image. And you can use that to sort of like tell if a specific image is deepfake or was generated using a large language model. Other forensic techniques that we're looking at are things like static and dynamic characteristics, where you can look at two images, even with the naked eye, and you can tell probably with the, the way the eyes or the way the hair is being shaped. You can also tell by those dynamic and static characteristics of what is deepfake or not. MMU also has got a research group that is part of the Alan Turing Network, or Alan Turing Institute as well. And what we're trying to do there is to encourage a lot of AI safety and AI ethics. So a lot of people that develop these LLM models, like OpenAI, like the ones on GitHub, like I mentioned, 11 Labs, are being encouraged right now to sort of like make sure that there is safety and ethics embedded into these LLMs. So if people are even going to be able to use LLMs to generate deepfakes, they should be watermarked, okay? They should be watermarked so that it's easier for them to be detected. Another scenario could be if you publish something using deepfake on YouTube, all right? You have to be able to disclose and be transparent about the idea that this was actually generated, like the video I showed you, that this was generated using AI. Okay, or it will be taken down. So a lot of social media things like X or formerly Twitter, YouTube, Facebook have been encouraged to embed AI safety techniques to be able to spot what is AI. And if it's not been transparent or the publisher has not been transparent, this will generate AI, it will be taken down to sort of like stop people using it for social engineering and scams or carrying out things like fake news. So quickly, I'll talk about some of the mitigations in terms of best security practices, zero trust policies. You don't have to take anything as face value. If you see anything online, you have to verify the source of that information. It might be a video, audio, image. You have to verify, have a sort of zero trust policy, especially within organizations, especially even with kids online, might be exposed to different type of content. You have to verify and don't trust some of these things. Educating employees and business partners, and like I said before, transparency in content creation and publishing on social media. Any questions? Any questions? Yes, please.
Thank you very much for the presentation. So probably it's more of a comment rather than the question. So what do you think right now? Companies that are faced with AI challenges, fraud coming from AI, is the gap widening between those that rely on human intervention and those that were born in the AI space? So AI challenges, AI solutions.
Yes, I believe this space is widening and is more of like a sort of a catch-up now. You know, like I said, the cat is already out of the bag. The can of worms has already been opened. AI has already been published, and these epics, this sort of like AI safety, is trying to play catch-up to this AI, generative AI models that are already out there. So the gap is widening, but what we're trying to do, and in terms of the government, all of this AI safety platforms, is trying to bridge that gap between where we are now and where we should be in the future by implementing AI safety and AI ethics into most of these LLMs that have been deployed. And also making sure that which one should be open source and which one shouldn't be open source in terms of publishing some of these AI language models for people to use. I was listening to a conversation recently by Sam Altman, who is the CEO of OpenAI, and talking about things like what should we make open source and what shouldn't we make open source. There are large language models that they are looking into that could do probably much more better than what they've got now. But the question is, are you going to make those open source? And to what level are you going to sort of like place controls on what people can do or what they can create with those sort of LLMs?
I mean, we could keep on talking, but I think we have to jump into the next session right now. Thank you very much.
Cheers, thank you.